Hey guys, so here in the first part of the transformations, we're going to be covering how to shift the function up and down. And from then on in part 2, we're going to get into the more complicated shifts where we do other stuff. But let's get started. So here we have that we will obtain blank functions from blank functions. So the point of transformations is that you're going to obtain a whole new function from the old functions that you already learned. Alright? So here also, before we start talking about the shifts, we need to talk about C. C always comes up because C is always going to be the constant that we use in calculus. So in this case, C, and in every other case, C is a positive constant. What that means is that if I add C, I'm adding a positive number, and then if I subtract C, I'm actually having a negative number. So let's talk about the first type of shift we're going to discuss, which is the vertical shift, right? So here we have f of x, which is going to be our function, that we're going to add C to it. So whenever we have a number adding outside, we have a plus C, it's adding outside, we're going to say that it shift C units, whatever number that is going to shift that many units up. So in the little blank here we have, whenever we have a number outside adding, it's going to be shifting up. So let's talk about that. Vertical shifts are always outside. And that is the main difference between a vertical shift and a horizontal shift. Where does it go? Where is the number adding or subtracting, right? So vertical shifts, outside. So now let's draw the common parabola you already learned, right? We're going to draw it in black here. So we just show that it's like the original one. Not the best artist, but I'll give it a shot. So here we're just going to draw a regular parabola, and then we're going to shift the C units up. So let's say in this case, C is whatever number. Let's pick a random number such as 4, right? So we're moving 4 units up, right? And then we're just going to draw the same function, same fatness, same skinniness, whatever, just 4 units up. That's all we do. Whenever we have the same function and just a plus 4, we're just going to have the function moving up that many units. So in this case, we just did f of x plus 4. So we moved it 4 units up, right? So now let's say that now we have f of x minus c, right? So now we have f of x minus c. So as long as the number is outside, we're just going to move it up or down, and when the number is negative, we go down. So let's draw again a black function, just so we can represent an original function. It's actually a really bad graph. There we go. We have our function, and now we're going to move it again. Instead of having 4 units up, in this case we're going to have f of x minus 4, so we're going to move it 4 units down. So the function stays exactly the same. I try to draw it as identical as I can. I'm not the best artist. So I'm just going to move it 4 down. And then I have performed a vertical shift, C units down. Alright, so when it's plus C, it's going to go up because it's outside and it's a positive number. And when it's minus C and it's outside, it's going to go down. So that's it for vertical shifts. Now let's move on to horizontal shifts. So I like to say these are a little more tricky. And the reason is because you're actually thinking opposite when you have a horizontal shift. So if I tell you something, if I give you a function, right? So we said that vertical shifts are outside, right? While horizontal shifts are inside. So what that means, right? What that means is that I'm going to have minus C or plus C inside of my function. So just to tell you guys, to give you guys a little example, let's think about something where you have x minus 1 squared, right? So that's an example where you have x minus a 1. So then you have a minus 1 inside, right? That's an example of that. And let's go to the other one where you have plus a constant. So x plus a number squared. So here you have a number adding, right? So now let's talk about the difference. So now you have a minus c. So when you think of a minus number, you want to go in horizontal shifts, you want to go to the left because minus is negative, and you think, okay, minus, negative side. But that's why I have the little opposite here, because whenever you do horizontal shifts, you're actually going opposite. What this means is that you have a minus a number, you're actually going to shift C units to, instead of the left, you're actually going to go to the right. Alright? So you think it's minus numbers, you want to go to the left because that's where the negative numbers are, but you don't. You go to the right. So let's say in this case, let's draw a parabola again in black. And you want to travel, you have x minus 1 squared, which is a parabola. So now you're going to move 1 unit, because your constant is c, 1 unit to the right. Although you have a minus 1, it's actually to the right. So your new vertex is right here, 1 away. And you look, your function looks exactly the same. It is now shifted 1 to the right. Now we move to the other one. So if a negative number, if a minus c has an effect to the right, what do you guys think a positive c is going to do? You're going to end up going to the opposite of the positive direction in your mind. And when you go positive, you think you're going to go to the right. But when it's inside, you're actually going to go to the left. So we're going to go to the left here. Oops. Let's just scroll back up. Sorry about that. We're going to go to the left. Okay? So we're going to again draw our function black right here, starting in its parent function. And now we're going to move it, since c in this case is 1, it's plus 1, we're going to move it c units to the left. So we're going to go over here, and now the red is going to be a transformation function, so we have transformed from the original form to 1 unit to the left. Alright? So now we have covered on how to do vertical and horizontal shifts, which are the first part of the transformations. Later on, we'll see how it can get a little more complicated when you have not just horizontal and vertical, but you have like all these things put together. You can even have horizontal and vertical at the same time, and I'm going to do an example about that so I can show you guys how it gets done. So now this is a very important point. When it comes to graphing functions, there's something that I actually learned later on in math, and it would have helped me so much if I would have learned it earlier in math. And that is the fact that which of the shifts do you do last? Out of all the transformations, there's like a bunch, we've only learned 2. Out of all the transformations, which one do you do last? And it is between horizontal and vertical shifts. Now, the last thing you do is you do your vertical shifts. Alright? And that's going to save you guys a lot of trouble. When you guys do all the transformations, leave the vertical shifts for last. And the good thing is that it's outside. So you can just deal with all the stuff inside, and then outside goes for it last. Alright? So outside for the end, and that is your vertical shift. Alright? So now here, I'm going to give you guys an example where you had to sketch the graph of x minus 2 cubed. Right? So if you guys remember, x cubed is an odd power. So we refer to the cubic function or the awkward function. And by the awkward function means that if a cubic function or an odd function never goes the same way. See, parabolas, they go like this, right? So like they're doing like the YMCA, whatever it is. But if you have an awkward function, you're actually going to like put your arms like really awkwardly and just go like 2 different ways. Yeah, this arm is going this way, this arm is going this way, or you're going to go like the other way, awkward. So here we're going to have the awkward function in its original form in black. The best of a sketch that I can draw there, just the awkward function. See, it goes opposite ways. And now we have a shift. Now, I don't tell you whether this is a vertical shift or a horizontal shift, but how are we going to see what it is? We need to look where the shift is, inside of the function or outside of the function, right? So when we look here, it is inside of our function. Let's use color red. It is inside of our, I don't know why red didn't go. Here we go. Color red. It's inside of our function. So when it's inside, it is horizontal, and horizontal is also opposite. Right? So then I have a minus 2. So horizontally, minus 2. I think I'm going to go to the left 2, but it's opposite. So boom, I'm going to go to the right 2. So here, I'm going to go to the right 2. These are actually 2, 4, 6. So just one little dash to the right. And I'm just going to draw my function. So now we have shifted it 2 to the right because it's inside. Alright, now let's go to example 2. In example 2, we draw our absolute value, or the vagina function. The vagina function. So here we have legs wide open, got the vagina, and now we're going to move the vagina a certain way. But are we going to move it side to side, or are we going to move it vertically? All depends what you want to do today. So here the function has a number adding inside or outside. So we look at this positive 3, and the positive 3 is completely outside of the function. It's outside. So in this case, the vagina is going to move up and down. The question is, what direction? Is it up or is it down? So with vertical shifts, the sign of the number tells you where to go naturally. It's not like the horizontal shift, which is opposite. It's like weird, you know? So here, the vertical shift has a positive. So positive, you go up, and you're going to shift your vagina 3 units up. Alright? And eventually we shift it down, and you shift it up. You guys get the idea. So now here, we're going to give you guys an example where you have numbers inside and outside. So I'm going to tell you to sketch the graph of the cubic function, the cube root function, or the sleeping function, like we like to call it. So here we have the sleeping function, and we're going to draw it in its original form in black. So we have it there in black. And now what we're going to do is we're going to first start off with identifying the shifts, right? So we're going to identify the shifts. We have a +1 inside. So let me not circle the whole thing, just the +1. So if we have a +1 inside, what this means is that we're going to go 1 unit to the, you think it's going to be to the right, but it's actually to the left. So 1 unit left. And then we have the number outside. So we're going to go 2 units positive, so 2 units up. So 1 unit left and 2 units up. Now the question is, does it matter which one we do first? And like I said, the last one you ever do is going to be your vertical shift. So we're going to start off with the inside shift, which is 1 left. So we're going to go 1 to the left, draw our center there, and just draw our sleeping function. Alright? Now we're going to go 2 units up, which is our vertical shift. So we're going to start here. Now we go 2 up. And now we'll just draw it right through. Alright? So now we have included a horizontal shift and a vertical shift all together. And we have remembered to do the vertical shift last. Alright? So now join me for some practice problems on transformations of functions.